Hi, I'm just going to show you the return on investment model used to enable staff such as learning consultants to more accurately calculate how much time and money it will take to produce a given online or classroom or blended training course. Let's have a look at the model, which is based in an Excel spreadsheet using Visual Basic for applications. I'll now go and talk you through how it works, essentially by example. So first of all, we go to the Inputs tab of the model and open the display input data entry form. Now on this form there's quite a lot of things, as you can see, different displays and units. The key thing to begin with, to get used to it, is just to focus on several examples. So let's take one and I'll put it into context for Surrey County Council. So for example, Leatherhead Social Services asked to speak to a learning consultant because they're interested in developing a fully online e-learning course. They have 50 trainees they want to train, which we set here under this e-learning course column. They also want they want to run a 2 hours worth of online training. How much does that cost? Well, if we look down the column, we can see that costs 158 hours, and the development, or rather the time taken, is 158 hours, sorry, and that in terms of the development cost, that equates to £3,318. Essentially, that's multiplying the average cost for a developer by the time. Now, as a further example, the same Leatherhead Social Services also ask, well, how much would an equivalent fully classroom-based course take to initially set up and write, essentially, I'm talking about here. So again, you have 50 trainees, 2 classes per course of 1 hour duration each, so it's essentially the same time as the online learning. And again, after using these drop down boxes to set the figures, we get a total development time taken of 6 hours, equating to a development and setup cost of £126. Essentially, that calculation is multiply the amount of training, 2 hours, by how much it typically takes to write 1 hour of classroom content, and that's using a ratio of time taken to develop is 3 hours for each hour of classroom training. Okay, so having now got those comparison, that classroom and e-learning course calculations, let's say the Leatherhead Social Services want the full estimate of how much it takes to develop, including the setup costs and running costs. So in this case, we keep our same figures for the development of the classroom and e-learning course, but we also add some additional things to represent the ongoing support costs. So for an example, this will be, in the case of classroom course, the physical classroom cost, £26 per hour. This is taken from the Surrey data from the financial accountants at County Hall. Also, printed materials. You might want to give a course brochure to each of your trainees. Now, we've got 50 of them. Let's take an average of, say, for each brochure to cost, say, £10. Also, we're assuming we're using internal trainers. And then going over to the e-learning course side, let's assume we're just going to host this for 1 year on the learning management system, be that Learning Pool or whatever else. So we'll just move that to 1. And the idea with this training is that the figures automatically update on the settings. You don't have to press submit and wait. It automatically picks this up. And as we can see at the bottom, we've got a total classroom cost now of £3,095. Total e-learning course for the equivalent training of £5,493. Now, as we're doing a comparison, we set this mode, the e-learning mode, with a little icon with a piggy bank to represent this as a course, a type of course comparison, obviously the comparison between classroom and e-learning, and we can see that that's the difference is in the red of 2,397, simply to represent that it's costing just over or £2,400 more to do e-learning than the classroom course in this context and with those figures and in that situation. Obviously that will vary depending on the particular context and the application. So obviously if e-learning were to cost less than the classroom course in a given training context, that number would be in the black. And if we're ever in a situation where we want to justify the advantage of using a full online e-learning course against a classroom course, it obviously goes without saying that if that figure's in the black, that helps your case. If it's in the red, the reverse is also applies. Finally, let's say that Leatherhead Social Services have had a think about this and they've decided, right, we want to double the size of our course in terms of duration, and we want to try both aspects, both classroom and e-learning course, i.e. to develop a blend. Well, in this case, as we've already got the settings for the individual components of the course, the 50% that's coming from classroom-based training, the 50% that's coming from e-learning based training, all we have to do now is to try and calculate our blend. Now to do that, if you just bear with me, called blended course. Down at the bottom of the screen. Now, apologise if that's, you can just see there it's come to a total cost of £8,588. That's adding both types of course together. So what we've added the two course costs together, that £3,095 and that £5,493. Okay, I just want to finally touch on this area, further analytics, in case you choose to explore it in further detail when you're using the model. It consists of three functions which I'll go through briefly in turn. The first is a graphical comparison between classroom and e-learning costs. So if I just bring that up and you wait a second, then hopefully a graph should appear. And what we're doing here is trying to establish the break-even point in terms of total development time and total course cost when the costs of e-learning, shown by this orange bar, exceed the costs of a classroom course. And this is to use to check the optimum point where those two costs for the two types of learning balance out. We'll look at the second of the functions in the further analytics. This is the e-learning training savings graphs. Again, just wait a second for them to render in an Excel. And here we are. Essentially, what you're trying to do here is to look at the total savings made by e-learning as opposed to a classroom course against the number of trainees, i.e. the total number of trainees. So in our previous example we'd be talking about 50, and also in the graph to the right you can do this again, this total savings made by e-learning as opposed to classroom per trainee. So you're dividing the value by 50 in our case, and you can see there's a negative saving up to about 60 trainees, then it becomes positive beyond that point. Likewise, instead of you can do the savings of using e-learning as opposed to full classroom course but against the total time of the classroom course. So again, this is for the full cohort, 50 trainees, and likewise you can divide it by the number of trainees to get the how, and you can see there's a more pronounced kink. But throughout in this example, it's always appearing that e-learning is not resulting in a saving compared to the classroom course. As you can see, it's all below the negative axis. Indeed, as was shown here in this graph. Now, if we can also look at a 3D depiction of this by clicking the 3D button here. Again, please bear with me as this takes time to render. Now, when this appears in due course, and as you can see, it's still thinking about it. Ah, brilliant, at last. All good things happen to those who wait long enough. You can see we've got our 3D depiction here. Again, the total e-learning savings per trainee on this Z coordinate, if you like, against course duration on, let's say, the X coordinate, and against this Y coordinate for number of trainees. Now, you can't do it within the data form view, but in the actual Excel spreadsheet below this, there's actually ways to rotate this graph, so perhaps you can get a better handle on how those three variables relate to one another. So this is, again, if you're wanting to get into more in-depth analysis in making your comparison between e-learning and classroom-based training. So I'll just close this. Both of these, you can see the close is obviously the little exit door icon there. Which finally leads me to our third of these functions, which is to display the Monte Carlo development form. I'll just bring this up here. Now, the idea with this is to get a more finely honed estimate of how long it would take to for a developer to produce a given duration of online learning content. So let's say we want 2 hours, 120 minutes of online learning. We can vary the number of iterations. What this is essentially doing is giving a guess on each iteration of how long it will take to develop this content, and it's doing a statistical average. Let's illustrate this, hopefully. So I'll reduce the number of iterations. It can go up to 100,000. It could probably go up to a far larger number depending on the power of the PC that's running this model. But because we haven't got infinite time, let's keep it at 10,000. If I go to run Monte Carlo now, and again you have to bear with this as it takes a bit of time to ramp up to build the model, but in due course this iteration count should go to calculating, and from then it should start counting up from 1 to 10,000 iterations. There we are, and you can see this is gradually growing. Each of those, this bar represents a different estimate of development time, and there's our average, 131 hours. The beauty is it breaks this down into the different phases of that e-learning development project. So you've got requirements capture, authoring, programming, graphic production, audio video production, QA testing. It's giving an average estimate of how long these things might take. Now, as with any project, whether it's doing software development or building a house, you have to treat this with some common sense and allow some variability and tolerance. But what it does at least give you is a best guess or a best estimate, that 131 hours it would take to develop 2 hours of online content, plus a variability in that guess, one standard deviation of 31 hours, which, as you can see, this helps when you just define a business case for e-learning, you can say, well, this is actually a fair statistical estimate of how much it's likely to take to develop, from which you can then feed this 131 hours back into your return on investment model to work out the cost that in terms of developer time that for this to be used in the project. So I'll just close that now. And as you can see, it's picked up that 131 hours into our model. Okay, thank you very much for bearing with me and watching this presentation. I hope you have fun and the ROI model proves helpful in your work.